This is a fill-in for the part of the proof that I wanted to give you a few more extra lines to. Sometimes I work on something in the morning when I have morning brain and it sounds perfectly fine to me without extra details, and then when I come into class after a full day of work, it doesn't sound quite right. So we were at step 4, where step 5, where we're trying to show set containment of I in the cyclic subgroup generated by A. So just to recap, we started with a Y in I. By the division algorithm, we're able to expand Y is equal to Q times A plus R. And the R must be between 0 and strictly smaller than A. By group properties, we know that R can be expressed as Y minus QA, that we're allowed to subtract the QA over. We know that Y belongs to A because that's where we started, and we know that QA belongs to I by step 4. Then R belongs to I by the hypothesis that I have double underlined over at the top up here. But then R must be 0, because by the division algorithm, we have that R is restricted between 0 and A. And if R was not 0, or it cannot be strictly positive, because A is the smallest element of I that is positive. So there cannot be another element of I that is also positive that's smaller than A. So that forces R to be 0. That means that Y is of the form QA, which is the definition of being in the cyclic subgroup generated by A. So therefore, I have set containment in the other direction. Hopefully this filled in the remaining lines, and let me know if there's a problem.